Okay, today I'm going to be working through problems with operations involving multiplying polynomials, adding polynomials, subtracting polynomials, and some of the distributive property. I'll be showing a few of the problem-solving techniques, so if you see one that you like, I encourage you to continue practicing it um, during class and on the assessments. So let's get started here. This is on page 106, problem number 1. We have 3x plus 4 times 2x plus 2. I'm going to show a table method of solving this one, and then I'm going to show the FOIL method on the other side. So I'll spend a little bit longer on the table method, just explaining how I'm setting it up and walking through the problem, and then the FOIL method will have all of the same principles. It's just a different way to think about it. I prefer the FOIL method because I don't have to draw a table, and that saves me some time and some space, but I also have practiced organizing, writing math and writing it on the page in a way that I'm comfortable taking these shortcuts. If this helps you stay organized but takes a little longer, absolutely use it to your advantage. Math is about being precise. So let's get started here. What we're going to do is we're going to take each of the terms and put them in their own box along here. This side over here is going to be put into this vertical column, and this side right here is going to be put into this horizontal column across the top. So I'm just going to start here. 3x is our first term. We're going to put that in that box, and then 4 we'll put in this box. Over here, our first term, we'll start here, put a 2x, and then this 2 we'll put right here. And it doesn't matter the order in which you put the terms within the boxes, it will all still work out. However, I recommend just following the convention of going top down and left to right. Doing things the same way, it will help you see patterns because you'll be used to it, and then if you see things that break from the pattern, that should catch your attention when we're working through problems. Okay, so for this box right here, we look at it, it touches this left side and this top part up here. So what we do is we multiply these two together. So when we have 2x, we have a constant and a variable. Constant and variable, we just multiply the constants together, and then we multiply the variables. So 3 times 2, we get 6. X times x, we get x squared. This one right here, it aligns with this 3x, and the one up top aligns with the 2. So we just multiply those together. 3 times 2, we get 6. And then we just have x. Okay, now here, this box to the left of it on its side is the 4, and if we go up to the top, it's 2x. So we multiply those together. 4 times 2 gives us 8x. Clean that up. And then for this one, we go over here, it's a 4, and we go to the top, it's a 2. 4 times 2, we get 8. Now we take all of these terms down here, and we combine the like terms. So I'm going to do this in 2 steps, but you could do this as we go through the table. So first one, we have 6x squared. Now I'm going to look through here, do we have any other x squared terms? These are just x. This is no variable, so no. So I just write that. And remember, when we are writing polynomials, we write the variable with the highest exponent first, and then we go down to the next lowest and the next lowest, and we descend as we continue writing. So here now I have an 8x and a 6x. Both of these have an x. They are like terms, so we can combine them. So I told you I'm going to write this in 2 steps, so I'm just copying all of these down here. But when we're looking through the problem, we want to be trying to spot these similarities and these patterns. The last term that we have here is just 8. There's no other term in here that just has a number, so it is by itself. Like we saw before, these middle ones are the like terms, so we can just combine them. If we have 6x's and we have 8x's, then we have 8 plus 6, 14, and we have that many x's. So we have 14x plus 8. And that is it. So we put a box around our answer, so we know that we are done. Okay, so the FOIL method. Look back at what we did here. This 3x was multiplied by the 2x and the 2 separately. This 4 was multiplied by the 2x and the 2 separately. So FOIL stands for first, outer, inner, last. And it's because we're going to take the first term of each binomial and multiply them together. And then we're going to take the outer terms. So this is the inside of the expression. This is the outside of the expression. So we do 3 times 2, or 3x times 2. And then we multiply the inner terms. So these are the outer terms. These are the inner terms. 4 times 2x. And then the last terms. So we have 2 of these. It's 3x plus 4. 4 comes last. 2x plus 2. 2 comes last. We multiply those two together. Now, this was just the mnemonic that I was taught, but the way I really think about it is just this first term has to multiply to both of these, and then this first term has to multiply to both of these. So now we have to go through, just do the multiplication. 3 times 2, 6, x times x squared, plus 3 times 2 is 6 times x, it's just x, plus 4 times 2, we have 8x, then 4 times 2, we have 8. So this is equivalent to the previous. Exciting. All right. So key part is that we distribute both terms, and then we combine like terms if there are any. All right, let's look at the next problem. So I'm going to show the table method for this one. Take this, the first term in this binomial, 5m. The second term is 3. First term in this one is 4m. The second term is 6. Now we multiply these together. 5 times 4, 20. M times m squared. Remember, anything times itself is just that squared. 5 times 6 gives us 30. And then we just have m. 3 times 4 is 12. We still have that m here. And 3 times 6 is 18. Now, the reason I was pointing out that you should set these up the same way if you're going to use the table method is because you could then always expect that if we have a binomial, we have a variable plus a constant, or minus, and a variable and a constant, then your like terms will always be just right here. So it saves you some looking around, makes these problems go a little bit quicker. So now we're just going to bring our terms down, 20m squared. And like I said before, I wrote it out last time, but when I'm at this step here, I would just go 30 plus 12, that gives me 42. So we'll just go ahead and save ourselves writing a whole nother expression there. And then what do we have left over? Just this 18. Then we can put a box around our answer. So we are done. M squared, m, and then a constant, no variable. So we can't combine anything else from here. Okay. Let's look at number 3 with the FOIL method. We have 6t plus 5. $7t minus 5. All right. Look out, we got a minus sign. This is where 99% of the mistakes that I will see happen with any of these problems. We gotta be careful about the minus signs. We gotta start getting real good with adding and subtracting negative numbers. So if you're having trouble with this, please let me know, and we can sit down during 6th period, probably take 20 minutes, and I'll help you get a new framework for thinking through it. Alright, so foiling, we're just going to multiply these first two terms, 6t times 7t. So 6 times 7 is 42. T times t, we get t squared. Now we're going to multiply these last terms here. 6t times negative 5. We have to use that minus sign in there as a negative. So 6t times negative 5, well, I just think about it as, what's 6 times 5? It's 30, but then we have to make it negative, and we have the t. So we do minus 30t. And then we multiply these inner terms. 5 times 7 is 35t, but this is positive, so we do plus 35t. And then we do 5 times negative 5, again remembering to keep that negative. So 5 times 5 is 25, but we make it negative, so we do minus 25. And now we combine these two middle terms here. We have 42t squared, negative 30 plus 35. So this 30 cancels with that 30, and there's 5 left over. And the positive number is greater, so we're at plus 5t, and then minus 25. We can put a box around our answer because we are done. Okay. Now I'm going to jump down to the bottom of page 106 and look at number 7. So we have 2x times x plus 6. So up here before, what we were doing is what we were doing before is we were multiplying a binomial with a binomial. Remember, it's a binomial because it has two terms, one with this variable and then this constant. Now if we look here, we do have a binomial here in the parentheses. We have x plus 6. But on the outside, we just have one term, this 2x. So this is a monomial multiplied by a binomial. This is actually easier. If we look up here, if we just got rid of this part, all we do is just take that first term and we distribute it to both of them. That is exactly what we're going to be doing here, but I will show how we can do this with the table method if that is the method you feel most comfortable with. So first we're going to multiply 2x times x. There's no constant, it's just a 1 there, so we just get 2, and then x times x, we get x squared. Then we have to multiply by the second term here. 2 times 6, that gets us 12. It's positive 12, so we'll write plus 12, and then we still have that x. And that's it. We are done, so we can put a box around our answer. Now let me show that with the table method. So remember before, the first binomial we put in this vertical column. The second one we put in the horizontal column. So we're going to follow that same convention here. So since the first expression is a monomial, we're only going to have one of these boxes in the vertical column, and it's that 2x term, so we'll write it right there. And then we have this binomial up here, so we take the first term, write it here, the second term, write it here. This box, we multiply these together. 2x times x is 2x squared, and 2x times 6 is 12x. And then from here we would just rewrite it outside of the table as 2x squared plus 12x. Okay. Let's see. I'm going to move on to page 107, operating with numeric radicals, where we are extracting square roots from radical expressions. So